All right, all right. Welcome everybody today to our webinar. Today we have the honor to have Martin Ulrich from Austria here with us. Hi Martin, how are you doing?
Hi. Yeah, I'm great.
Okay,
Weather
nice.
could be better, but
Well, you will feel better after the talk, I guess. Anyway, I must say Martin is one of my go-to guys for asking MSBuild questions. So I really can recommend you to stick around and watch his talk. So his presentation talk or his talk today will be about tips and tricks to improve your .NET Build setup with MSBuild, and just some basic things also. Let me switch the slide. Now, we will record this webinar, so if at any point you need to drop out, then you can still access the recordings afterwards. But it would be nice, of course, and I must say, for me, it's always worth to stick around, so even though I work with MSBuild a lot. And if you have any questions, you can ask them during the presentation. If they fit right into the moment, I will ask them right away. Otherwise, we may postpone them to after the talk. And with that said, Martin, I will hand over to you. And I'm really excited to see your presentation.
yeah,
Okay.
thank you so much. So thanks for joining. Thanks for the opportunity. Again, please feel free to ask any questions. Materials will collect them, and even afterwards, you can also find me on Twitter or and shoot me DMs or find me on Stack Overflow, etc. So also Stack Overflow, really good resource for asking MSBuild questions, because there are also people from Microsoft answering. Plus, MSBuild is open source, so you can even open issues on the MSBuild repository, so .NET/MSBuild. But short introduction, my name is Martin. I work for K2Every, which is a consulting company. I do a lot of DevOps stuff, so managing build processes. So yeah, I got really into build setup and working with .NET tools. I was also a bit active in the community when there was a switch from Project JSON to MSBuild. So that's basically where I learned MSBuild, by like trying to adopt .NET Core and using it and setting up build processes around it. So that's kind of the experience that I had with MSBuild. So I hope I can share a few of these learnings now with you. So the goal for today is I would give a few introductions or basic refreshers about some basic concepts of MSBuild, and then show you some practical examples on how to put them to use to do some build customizations. And I hope we can also have an interesting Q&A afterwards. So just a short introduction. MSBuild really deals with XML files. So I'm sorry about that, but that's the way it is. But basically, any XML file that confirms to this MSBuild format, so has a project root element, is actually an MSBuild file. So a lot of them, that is mostly naming conventions. But even though you may have seen like .NET Core projects, .NET 5 projects, which are kind of human readable, it's actually not really a configuration language. If you squint really hard, it actually looks like a programming language, because we do have properties which are like variables. We do have like objects and collections, which is called items in MSBuild. And we have our build logic, basically those targets that are built, composed of tasks, which are like individual steps that contain logic. And we even have like control flow conditions to allow us to have some if conditions, so control flow, even some basic forms of loops. So it's really kind of a programming language rather than a configuration language. So that's also the real difference to things like Project JSON, which has been around before, which is also what makes MSBuild really useful for configuring parts of the build process or doing some small customizations directly in the same format that you actually configure your project with. And again, most of the things in MSBuild are more convention-based than actually hard rules. So for example, every project usually has a file name that ends in proj. So CS_proj for C# files, VB_proj for Visual Basic projects, FS_proj for F# projects, and so on. But again, any XML file that matches that format is actually able to build with MSBuild or be loaded by MSBuild. If it's actually doing a build or doing something else is something different. But then there are also different files. So a project file is usually not the only thing that's being used in a build. So usually you want to reuse some logic. So you have different files as well. And those are typically named .props or .target. So if you look at like build logs, you will see sometimes like .props and .targets files imported from some .NET SDK location, or any custom files that are contain like shared values for your solution, which I will show you later. And that's basically more a convention that you say, okay, some of the defaults and some configuration objects is usually land in .props files, and some things that are more logic usually land in .targets files. But again, those are mostly conventions. And also when you look at some build logic of the .NET SDK itself, there is basically, again, there are variables like properties and items, and you can configure most of them yourself or hook into targets, but you will see some of them have like underscores in front of them. And underscore is basically the convention for saying, okay, this is private, this is not meant for public customization. But if you find anything that is not prefixed with an underscore, it's usually open for customization. And even the MSBuild team really does a lot of work to make sure that those non-private things are actually stable from an API perspective, so that a target is not renamed arbitrarily. Yeah, but if it has an underscore, it means like don't touch it. So I think the most I've seen is like 3 underscores in the .NET SDK. So that means like, yeah, that's subject to change and may break in the future. So I quickly want to show you a few examples of what the MSBuild file structure and the logic looks like. So I'm going to just show you a code, and like what's the start code that we write with any programming language is basically a hello world. And so this is already a bit advanced hello world. So let me quickly walk you through it. So actually this is now a project file. It's an XML file that has a project root element. So it's already able to be loaded into MSBuild. And what we can have in here are like these variables. These are called properties. So we have property groups that can contain these properties. So we set greeting to some value. Let's focus on that right now. And then there are targets where we actually have the build logic that we want to execute. And then tasks inside of these targets. So in this case, there is a target that is named greet, and it writes some message on screen. The importance is basically a log level, and anything else is basically some input to these tasks. So we will be using the message task now, which just should write something on screen. But you can also see there is like these fancy syntax that has like the dollar is able to substitute the values of any other property, so variable basically. So in this case, we would set greeting to hello, and then whatever the person property would be. But also we have some control flow on here. So there is a condition, which is basically something that is being evaluated. So in this case, it checks if the string representation of this person property is actually set to some value, but actually it isn't, right? So because there is no person in here, so this would actually now do nothing. And on this target, there's also a condition, so there's also control flow involved that also checks for the person and also for some other stuff in here. So if I try to run it, and actually how do I run it? So usually when we use CLI tools, we would do something like .NET Build and so on. This is meant to be run on project files, but if you want to use like very basic MSBuild logic, it's best to run .NET MSBuild. So behind the scenes, any or most of the .NET SDK commands like build, publish, pack, and so on, actually execute MSBuild targets behind the scene. And it's just a fancy way of, for example, writing MSBuild, target, pack, and so on. In this case, we would just run .msbuild, and it should automatically find this .proj file in here because it's the only file that is named with something proj at the end. So, and of course, it does nothing. So I would need to set this person to actually produce some output. So I can actually do that using property person Martin. So we can set any property from the command line with property. Right, hello Martin. And this is actually one of the ways that the .NET SDK passes a lot of the options that you can pass to .NET Build and so on as a property. So for example, .NET Build configuration release is actually kind of similar to running .NET MSBuild property, or P for short, configuration equals release. So a lot of these directly call it MSBuild. And then a pattern that's also very highly used is, of course, now we can have a property, but again, there is a different condition in here as well. And there are usually configuration options for many of the standard targets where you can switch something off and on with different properties. In this case, we look at it, it's greet, it doesn't have an underscore, so it isn't private. So we can actually set that. So maybe set greet false, and we should not greet anymore, even though a person is set. So those are the main logic functions and main elements in MSBuild. But of course, properties, these kind of variables, aren't the only thing. So the next thing I want to show you are items. So properties are like these key value pairs that we set. So we set a property to a value. Items are more a collection. So in this case, we don't have a property group, we have an item group. And we do have this person element here, which is basically the type, so to say, of an item. So basically we say, okay, there are collections of persons, and we add something to these collections of person objects, so to say, items. In this case, there is a syntax for this using include. So in this case, we're including two elements. So items are usually separated by semicolons. So in this case, we add two items to this collection of items in this line, and then another one in this line. So we should have three person items in our person items collections. And we have a similar target in here that greets all these persons. In this case, we don't use a dollar, we use an @ to reference items. So if I execute that, we can see that it finds all three elements and joins them together using semicolons. Of course, semicolons are usually not the only thing we like to do. Sometimes we want to not use these concatenated syntax, but do a transformation. So we can actually use this syntax to perform function calls or transformations using the source items and projecting them to new items. And then we can actually reference some properties, or actually it's called metadata on these items. In this case, there is an identity metadata that's basically the main name. And if I run that, then we can see, okay, we now have three hellos, but maybe we also want this semicolon to be gone. We can actually replace that with an XML encoded new line as well. So just a few ways to do transformations. But of course, you will have seen this for customization objects in project files. For example, we can add NuGet package references to C# project with project package reference items. And you've seen this include syntax probably if you've looked at the source code of your project files. But of course, there are other syntaxes as well. So for example, we can so just copy that up there. So for example, we can also use a remove syntax to remove something. And of course, we can also define properties that use this special semicolon way of structuring things. So again, this is a property, so it will have a string key value pair that is just inserted into an include definition. So we can actually remove Martin and add some more elements. Right. And this is basically how we can work with items. So we can include them, remove them, and there is also an update if you want to change any of these metadata additional properties. Speaking of metadata, since properties can represent basically anything that we want, properties can also reference files, and this is items can also reference files, which is actually the most useful use for them. So if you have any source code in your C# project, which you hopefully have, those are each of these files will end up as an item as well. So, for example, if we have these C# files, they would be picked up by a glob pattern that looks for star.cs. In this case, I have prepared some greet files like a Christina greet text, Martin greet txt, and so on. And I want to actually read those files and write greetings based on the file content. So in this case, I create an item group, and in this case, I create greet file items. And in this case, MSBuild will say, okay, does this string, or in this case, this pattern, match any files on disk? And in this case, it will match all the .greet.txt files. So in this case, we would have two items being created by MSBuild for us. And then in our greet target, let's run it first to check if it's working. Right? So we can see there is content from both files being used. The way we accomplish this is now we use some other tasks as well, not just the message task. In this case, we can use read lines from file, where we can say, please read from this file. And in this case, I actually just want to pass, pass all files. In this case, this task only supports one file. So I kind of need to do some sort of for loop. And in this case, I'm using this %syntax reference to reference the metadata identity, so basically the name of greet file items. And what this will do is actually the so-called batching, is it will do like a bit of internally a sorting for all the objects that match this identity. So for each unique identity, I will have one value, but since we can't have the same file name multiple times, this is basically a for each. Yeah, so batching can be quite complicated and mess up your brain. But in this case, if you just use it in this way, have just one reference to one metadata, it's just a for each loop. So we use this read lines from file task, and we can also access output parameters. So there is a parameter on this task called lines, and I know this because this is documented in the read lines from file task, and we create greetings items from each of these lines. So now we should have more greeting lines, and then we can use similar message tasks as before to just output these greetings, basically these files. So if I write something here, it should appear here as well. And since I've mentioned metadata as well, there is some default metadata that's available for all files. So each item that matches a file will also have some metadata available, like full path, modified time, and so on. There is a documentation on that as well, which I have in here. By the way, this report, all this code is available on GitHub, and I believe Matthias can also post a link to that in the chat. So here we'll also print which files have been used to create these greetings. Okay, so, and there is one more caveat that I want to mention for items and properties, which is useful when you actually configure some projects. So usually when you have a CS proj, in this case, there is a sample Razor project, you usually have your project configuration. So basically those key value pairs, you set a few of them in your project body, but there's this magic SDK reference. And what this does is it will like textually add some content before all your definitions and after all of your definitions, based on what this resolves to. But the idea is that, some defaults will come like before your project, like what would be your default bin and object directory path, etc. And there is some build logic that comes afterwards. It basically looks at, okay, what have you set target framework to, etc. So there will be some content added. And if you want to do some customizations, especially to items, it can look a bit interesting. And this is because evaluation order is a bit different than from what you would expect. So for example, This is a project that replicates a few of these behaviors that you get from the default.NET SDKs. So you would have like a target framework and so on. But the idea would be that in the defaults, some items would be defined looking for some properties. So for example, in the .NET SDK, you would have something like enable default compile items, enable default content items, and so on. And if you set them in your project file, this would actually be textually after some default item includes. And this is because MSBuild scans first all the properties that you define. Then there are also things that I didn't tell you about, which is item definition group, which can set some defaults for items. In this case, on each of the files, we can set some metadata. So you have the identity metadata, which is basically the name that's used in like include, remove, and update. And you can even set any different key value pair as a metadata on these objects. And some of that can be also done using defaults from item definition groups. So after properties, it will parse these definition groups, and then it will parse again from top to bottom the item groups, which means all of your properties are read before all of the item groups. So if you do anything interesting like having NuGet package references, include MutualSoft, JSON version, and so on. And we want to set like a condition on that to do this only if like our target framework is like maybe .NET 4.8. This will still work because again, these properties will be parsed before or evaluated before any of the item groups. So this is where like the positioning of properties and items can be a bit messed up in your project files, and you will see this a lot of time when you use like .NET add package and so on. It will still work. So just a thing to watch out for. But this also means that any of these default files that are included, for example, it includes all greet.txt files as greet file items. If you want to change any of that, maybe you want to change an item from being a greet file to maybe being an embedded resource, you need to remove it from one basically collection of items and add it to another one. So when you update files in the Project Explorer or project property or file properties, this is the code that will usually be generated. So if you have a look at that for our sample project, so the web SDK actually, because it's a web project, we have like these app settings JSON files that we usually copy to the output directory, and these are actually contents. So maybe if you want to set that from content to like embedded resource, and maybe don't copy it, what we get is, okay, we need to remove it from the list of content files and add it to embedded resource files. And again, there are some things that we configure on these fields. For example, do we want to publish them, copy to publish directory, let's say never in this case. This is what we would set here. And this is because, again, some of the defaults come before your project file. But again, if you see, this is called content. If we can set, I believe it's enable for content items force. I believe this now should be build action none. So nothing. So you can see that basically these things that you can select in build actions actually resemble the items that these will end up as. So just checking. These were like a few of the basics and advanced basics actually. So again, properties, key value pairs, there are a few that are reserved or well known, like you can access MSBuild versions or operating system variables. And again, things that you're actually passing from command line may behave a bit interesting because they can also override stuff in the project. Please refer to the link documentation for more details. And again, items are like collections of objects that have a basic identity, so that a key and some metadata. may or may not represent files on disk, and some glob patterns are used to also look for items or files on disk. And there are some basic looping or grouping behavior called batching. Please refer to this documentation for more details. So if you need to write any custom logic, we use targets, which can contain one or more tasks. And again, these form basically all of the build logic that is in .NET projects, because these targets form like a target graph, which you can also hook into, which I'll show you later. And of course, the evaluation order is defined as such. The main takeaway is that like all properties and also like imports, if you want to take things from other files, are evaluated before items. It's just the main thing to keep in mind there. So, and with that, I want to put this knowledge into use and show you a few of the practical examples for customizations that are either interesting to see or really good to know to use in your next project. So, for example, a feature that was introduced in MSBuild, I believe 2 years ago or so, is called Directory.Build.props and Directory.Build targets. Again, I've mentioned these are kind of like conventions of what project files are named. But usually how it goes is you have a solution, you have lots of projects in there, maybe 100, maybe 200, maybe 2, and you want to set a few properties or a few configuration values for all of them, which it can be quite tedious. Whatever IDE you're using, that's usually like right-clicking or setting properties hundreds of times, which is really quite tedious. So what you can do is create a Directory.Build.props file somewhere in your repository structure and set configuration values in there. And those defaults will be applied like before or above all of your project contacts. So everything that you want to set globally in your solution, it's very easy to do in there. For example, maybe I want to set the version number globally for all my projects and not have to update all the projects individually, or set some metadata for that will end up in NuGet packages or assembly infos like authors, company attribute, etc.
Martin?
And also, yeah.
Really quick, I just want to inform you your camera has no signal anymore. So you can decide either we just show your screen or if it's just switching off and on.
Is it back on again?
It's back on, yeah.
Okay.
Okay.
Then I suspect it's an overheating bug as well, since obviously my white balance settings are also off. Quite interesting. So yes, also what I wanted to mention inside of these Directory.Build.props files is something that's very useful to do is also using conditions here. For example, if you want to treat warnings as errors, that is also something that you can set in here. So let's just quickly show you how that works. So for example, if I build this project file, I will get this warning, yeah, there's an unused variable. And unused, okay. By the way, if I do .NET run in here, this will print the current version information, and this says it's version 1230. Again, this is not set in the CS prod file, this is set in the Directory.Build.props file. So basically all this global configuration from a complete solution. But maybe I don't want to have anyone commit code with unused variables to my source code repository. So I want to enforce that all of these warnings are actually errors. But maybe I don't want to do that for like debug mode, where you need to quickly prototype some code or refactor something, like change some code, like do a return or log and set a breakpoint, and the rest may not be perfect. And in order to not block that, I just want to set this for release configuration. This I can do using a condition. So again, I want to check, is the configuration set to release? And if so, treat warnings as errors will be set to true. So if I build this in release configuration, so C release, this is now actually an error and will fail the build. And this is something that's very useful for CI systems as well. And of course, if you have any targets or anything that you want to like base on configuration that was set in the project file, this has to go into a directory build targets file. So in this case, I want to check if it's a .NET Core application and it's published for a runtime. So you may have seen something like .NET publish -r. So maybe if you publish for Windows x64, this will map to runtime identifier. So if that is set, and it's a project that actually has a runtime output. So if you set the output type is either executable or Windows executable, exe or WinExe. This is just a property that the .NET SDK offers you for easier checking for all of these values that could be set in this output type. Then we maybe want to set some defaults for publishing projects. So if I execute this publish here, what did we say? We have a single file, but not self-contained. So we don't want to have all the .NET runtime in here, and we want to do publish ready to run, which will actually do some pre-jitting, so pre-optimization of the code that we're building. So if we have a look in this case, I did that for debug. Or did I? Debug. Just to give you, so all of these properties have been applied, and a lot of these properties that I just showed you, these are actually documented. So there is a new piece of documentation in here in the .NET Core Tools section for CSproj, and some of them document the actual things that you can set for this NuGet metadata. And the new piece of documentation that I wanted to show you, there are project SDK documentations. So for each of the project type, so basically these net SDK properties are all available. There is a documentation now for most of the things that you can set in the CSproj file. For example, runtime configuration. If you want to set your garbage collection settings, tiered compilation, all of these are now documented as well. Really useful piece of documentation now that was created, I believe, earlier this year. And very useful to now then apply to these solution-wide configurations. But if you maybe have like different source trees, maybe some projects like to split into like source and test directories. Maybe you want to have like different set of rules applied to these directories. So for example, this treat warnings as errors is something that I maybe only want to set for my source directory, but maybe the tests don't have like these strict rules. Then I also want to have a Directory.Build.props file in there that maybe sets, okay, all of these maybe libraries want to generate XML documentation, so you get all the warnings and errors from like missing these XML documentation comments. And they want to treat warnings as errors when we are in release configuration. Just a note here, this condition can be both either in the property or on the whole property group. So you can put these conditions on like any level. But since it's named Directory.Build.props, MSBuild will only load one of them. So this sample app will check the directory hierarchy until it finds the first Directory.Build.props file. And if in there we know that, okay, there should be another one like a few directories up, you can also use an import statement, which can import different files as well, and then execute some functions. In this case, this is called a property function, where we can call into some functions that MSBuild provides. In this case, we want to call getPath of file above, which basically means, hey, please look for a file in Directory.Build.props in, and now this is also a bit special. So again, there are a few special or well-known properties that MSBuild predefines, and one of them is, okay, there's this property MSBuild this file directory, which will always point to the directory that this file is in. And we say, okay, please look one directory up, because if we didn't do that, then it would find this file in itself and cause an infinite loop. So this is basically a search for the next higher up Directory.Build.props file and import that, which is useful if you want to have like different configurations for parts of the project. So for example, if I run a .NET Build in here, you can see there are two warnings, one of them from a test project, one of them from a main project. If I build for release now, you can see that only one of them will become an actual error. So that's also quite useful when using this kind of central configuration. And speaking of central configuration, there is a new feature in NuGet. So usually when you have like multiple projects in a solution, you want to have NuGet package references in multiple of these projects. Maybe you're referencing a data framework core from different parts of the application. Then you want to specify these package references inside of the project file. But usually you would say, okay, we're including this item, but usually you would like set a version in here, like version 3.1. something. In this case, NuGet has actually a new feature for this, which is called Directory.Packages.props. So this is a logic that NuGet provides. So all of the project types that implicitly use NuGet now, or the newer MSBuild or MSBuild distributions like the .NET SDK, right, or Visual Studio, will also look for this Directory.Packages.props files, which in the future, hopefully near future, the tooling will be able to update. This is something where we set different types of items, so-called package version items. So we declare for every project that wants to reference Microsoft Entity Framework Core, please use this version. So we set a global version in here. We also say, okay, please opt all projects into this central version management. I'm not sure if that's going to be necessary to be used in the future. Right now, I believe we have to set this to true. And if that is set and we define the versions here, we can then have references in all of the projects without caring about keeping these versions in sync across all projects. So really useful new feature of NuGet. And also speaking of versions, something that I like to do is I like to have my builds versioned depending on the actual Git version. And what I want to show you here are a few build customizations that are not just MSBuild, but there is a nice tool that's from Andrew Arnott called nerdbank.git versioning, which actually has a .NET tool. So if you do like .NET tool install -g nbtv nerdbank git versioning, this would install the tool. But if we have a local.config.NET tools JSON folder, we can actually reference the tool locally. By the way to create this, if I delete this folder, would be to create a .NET new tool manifest, I believe, right? This should create this local.config folder and a JSON file in there. And if we then use .NET tool install local nbgv, it will basically add this tool definition to this JSON file, and it will be available locally. So maybe if you have a project that maybe uses .NET install local .NET EF for like entity framework tools, you can also use a version in here to maybe specify you want to use like version 3.1 or something like that, to maybe separate, okay, here using 3.1 here and maybe 5 in a different project and so on. And you just want to make sure that you reference a version of the tool by a version number with intent and not by accident. And what you would do, like when you clone that repository on a new computer, or maybe you run or you run this during your CI, what you would do is .NET tool restore, and it would just make sure that everything that's referenced in here is actually downloaded and locally. We can then run .NET MBGB, right, which would give us more options. And what I actually wanted to show you here is once we set up this tool using MBGB install, what this will actually do is, or should have done, because I actually deleted the JSON file. Oh, perfect. So let's just fake that. If it should create a version.json file in your Git repository, so you can specify something like maybe the main branch and my version branches are things that I like build public versions from. What it will do is use this base version, so maybe let's leave it at 1.0, and increment this version for every Git commit. So the next version would be like 2.3 and so on. The way this works is that it also creates a Directory.Build.props files, which also contains a package reference item that will be included in every project. So again, a way to like add things to all of the projects, in this case an item, which contains all the necessary MSBuild logic to hook into your builds and set your build versions. So I believe I set this sample app up to print its versions, but if I do it .run in here, yep, it says it's version 1.0. Let's just print a quick commit. And I change something. You can see that this version here actually increased. So we increased the version. And what we can also do is get these versions out, and these are very useful to use like for CI processes, so where like version numbers can be based on your actual Git version, and this integrates nicely with MSBuild to set all your MSBuild metadata as well to be used later. And you can also use this cloud build functionality to like set the build number in the environment you're running in, like GitHub or something else. So just a nice tool to use. So, but then to something maybe more locally, and something that I've always seen is people try to use Xcopy inside of some build scripts to copy files to output directories. So in this case, maybe I have a shared files folder with maybe a folder structure, like a few files in there, and I just want to have these copied to the output directory of some project. I've seen a lot of people use Xcopy for that. Please don't do that anymore. It doesn't even work on like macOS and Linux, everywhere that .NET Core runs. And what we can do there, both for local files, is we can set some metadata, like copy to output directory, which supports a few options. One is never, which is mostly the default, preserve newest, also called like copy newer, and always to always copy and overwrite the target file. Please avoid using always. Like IDEs like Visual Studio that try to do some heuristics on do I need to call MSBuild to rebuild this project. Will actually say, okay, if you set something to copy always, the project can never be up to date and it always has to be rebuilt. So kill any performance optimizations for building projects. But for like a shared files folder that is outside of a project directory, you can do it like this. You can create like none items because it doesn't have any build actions like compile or embedded file. You can also set this to content. Then use a pattern to include these files. set copy the output directory to preserve newest, and then also specify link base, which can tell the system to put this in a different subfolders. In this case, there's like text files that I want to copy from a shared location. And if I want to build that, right, you can see that in this text files folder, we copied all of these files from the different location. So no need to use Xcopy. Can all be done using pure MSBuild. So, but if you want to actually distribute some files with something like a NuGet package, you can do this as well using MSBuild. So in this case, I've set up a library project, and this library project has a class and a very important file. Also needs to be copied to the output directory. This could be something like maybe a time zone database or something, or maybe even some firmware for devices that you work with, etc. Something that you need to ship with your NuGet package. And in this case, I want to mark this file as, okay, it needs to be also added to a NuGet package. So if I call .NET pack, I want to have this in inside the NuGet package, and I want each referencing project to also make sure that the file in the package is actually referenced and copied to the output of the referencing project. And the way to do that is, first of all, we need to make sure that this is not a none item, but a content item. So we remove it from none and move it to content. This should automatically happen if you do like properties and set it to content. Then there is some metadata that is available. One of them is pack, which means included in a NuGet package, and package copy to output true, tell referencing package projects to copy this file to the output directory. So in this case, I've also done a bit of magic to make sure that this lands in a local folder called nupcakes. Yeah, I like to pronounce it nupcakes because it sounds like cupcakes. By the way, for this, there are also MSBuild properties. Like we can create a custom property that has the path to this folder and then use package output path, which is basically what .NET pack -o translates to, like telling projects where to put the output packages. And we can use restore additional project sources, which tells NuGet, hey, this is also a source for NuGet packages. You can put both like HTTP sources in there, but also any local directories. So in this case, there is a package that was produced here. We can have a consuming app. That just reference, if I don't have keyboard one, that just references this content. Actually, this one is necessary. Got it over from a different stuff, and that just references this package. And now we try to build that. Let's see. Right, this important file ends up in the output directory. So again, a lot of things that we can do just using MSBuild-based customizations. So then I want to show you a few settings for actually publishing your app. So previously, I mentioned that you can set like defaults for when you try to publish an app. A lot of these publishing options are really MSBuild based. You can set a lot of them from IDEs, from like publish dialogues. But again, right-click publish should be forbidden, in my opinion. So I've set up this sample project that is a .NET project. It also has a text files that need to also be added to the output. And let's just explore a few of these publishing options. So I've done this using an import that just tells it, hey, please import, in this case, the file 1, which just sets some defaults. So in this case, self-contained. So you may have seen .NET publish, self-contained, and so on. And actually, if you set a runtime identifier, so in this case, I say, okay, we want to publish Windows 64-bit, Maybe I should remove the file because I don't have the right version installed, but it should work now. So in this case, I can say, okay, if a runtime identifier is set, I want to set self-contained to true. Should I think be the default, but you can also set it to false because in this case it will copy the complete .NET Core runtime, which is a lot of files. Maybe I don't want to ship that with my application, so I can set that to false, and then it will just publish basically a host, an executable by default, and just publish the application itself and not the complete runtime. But what I can also do then is just if I set it to false, then maybe one of the things I can actually do is run the JIT compiler to optimize the binary. So it should have faster startup time. This is some of the things that is useful to do for a runtime. So if we have a look at that exif file, I believe we should be able to see this. This is 140 kilobytes. If I execute this now, or sorry, the DLL file that we wanted to look at, now 4 kilobytes. What this will do behind the scenes, it will run the JIT compiler and pre-JIT a lot of the things that you're using inside of the application. So that it has to do less work when actually starting up and running your code. So that some of the platform independent code will already be pre-JITted or pre-compiled harder for the platform which is quite a useful feature now in the .NET SDK. Also, in this case, what you can also do is so-called single file deployments. So there's this publish single file flag, which is maybe if you don't want to ship a lot of files. So maybe if you want to actually do a self-contained deployment, which means please ship the runtime along my app. I just want to make sure that this is a single file. Publish, yeah. Actually, let's show that for different versions of the .NET runtime. So if I do this in .NET Core 3.1, publish, we end up with just one file and the text file. And what this does behind the scene is when I run this file, the actual content will be extracted to some temporary directory. So there's like your app data, local temp.net, and so on. And there is then a folder named after executable with some hash values in there, which extracts all of the necessary files, which is maybe not what you wanted. Actually, I should run the right one if I want to show you this. So I believe this, yeah, was the wrong one. Yeah. So if I run basically this hello world file, behind the scenes it extracts everything into this temporary directory. So it's not really a single file, it's basically something like faking it. But in .NET 5, the runtime is actually able to put all of the non-native files, so all of the IL code into one file, so that you just need to extract the local or the platform native directory, platform native files, if there is a true single file deployment. The way we can actually configure this behavior is by setting, in this case, include native libraries for self-extract. So this is, if we would not have set that, what we would have ended up with is single file, yes, but this property not set to true, which should be the default. If it will publish for .NET 5 self-contained, is you would end up with one exe file and a few native files, in this case DLL files for Windows, SO files for Linux, and so on, and of your static content. And what we can do then is set include native libraries for self-extract, which will also put all of these native libraries inside that exe file, but then use this extraction process behind the scenes, and also include content files, so like text file in an extraction process. And the same is if you actually want to include symbols as well in this process. By the way, setting symbols is also interesting because .NET now is able to actually include these symbol files, like the PDBs, inside of the actual DLL file that's produced. This is called debug type embedded. So if you want to reduce the number of files on disk, this is a great option to do. Right. So let's leave that as that. So then another interesting thing, when you, which is just a tip for CI systems. So I like to usually build my code on Linux, and maybe in some larger projects I still have .NET projects. In this case, maybe for .NET 4.6.2, either in the new SDK format or the previous long CSS format. In this case, I should be able to build this because I believe I have the right targeting pack installed. But sometimes you don't have like the .NET 4.6.2 targeting pack installed or the .NET 4.8 targeting pack and so on, and you would get a build warning. Or if you actually use the Windows subsystem for Linux, right? And I want to try to build this here. Yeah, it will actually fail quite hard because there is no reference assemblies for .NET Framework found, and I can't really install the targeting pack in there because it's like an MSI for Windows. And yes, there are some workarounds to use Mono for that, but a way easier workaround is to use a package reference to a new reference assembly NuGet package that Microsoft produced, Microsoft.NET Framework Reference Assembly, and also set some metadata to make sure that if we were like building a library that maybe multi-targets to .NET Core and .NET Framework, and we just run the tests on .NET Core and just make sure that we don't end up with some dependencies, this should build fine on Linux. Just we would want to make sure that this NuGet package is not actually one of the public dependencies of our project, so we can set private assets to all, which means all of the things like reference assemblies, content files, etc., are not forwarded to reference in projects. And if all of these assets are not forwarded, so all of them are private, then it actually won't end up as a public dependency in the project or your NuGet package. So this package is now referenced. So if I try to .NET build again, okay, it actually works now. Okay, so it was able to build this exe file. Of course, since this is now Linux and I don't have any Mono installed, I can't run this exe file, but I was able to build it. So this is quite useful if you do like NuGet packages that multi-target to different target frameworks. For example, if you target core app with one. Which version did I use here? Yeah. I should be able to build both the .NET Core and the .NET Framework slice without having to switch to Windows just because I have a .NET Framework slice as well. So then one more sample for bit of an interesting problem is that sometimes you reference APIs or codes that is not available on any framework that you target. In this case, maybe we target .NET 5. Maybe we want to do it similar, like building libraries, target multiple target frameworks, maybe .NET 5, maybe, .NET 4.2, maybe .NET 4 with 1, etc. And sometimes, depending on each framework that you actually target, you will have like different APIs to use. So you could do something like use if, and some of these values that you can use in here are actually predefined. So for example, one of them was like debug, the build and debug configuration. I believe this should be the default if you target like .NET 5, but there is nothing left like if at least .NET Core 3.1 or at least .NET Framework 4.8 and so on. So that doesn't really exist. But again, you should really be focused on what kind of features are you actually using. And what you can do there is actually use some MSBuild logic, custom MSBuild logic to define like feature flags. So in this case, I copied some feature flags from a project on GitHub and just made to show you how this could be done. So for example, if I have something like at least .NET Framework 5.0 is something that should be available on the minimum target framework versions of maybe .NET 5.0. Then this elliptic curve with DSA is available like on .NET Standard 1.6, but also on .NET 4.7, and so on. So I have a few. This is service provider in HTTP message handler builder and so on is only available on these .NET Core versions and .NET Standard versions and so on. And the idea would be that if you target any platform that is compatible, maybe .NET 5 will be compatible with .NET Core 8.2.2 and .NET Standard 2.2, so maybe we want this feature flag to be defined. And the way we can do this is actually create a target that creates these compiled constants for us based on these definitions. So in this case, I have a custom target, and we actually can hook this target onto a different target. So we can say, okay, there is a public target that is available for customization called before compile, and I can actually hook before that. And just by looking at some documentation in source code, I can tell you this is where we actually want to hook, so that these constants that we define actually are picked up by incremental compilation, which is also a feature that both targets can do and so on. So what I want to do in here is create a few intermediate items because we need to maybe shuffle this around a bit. So in this case, I want to use batching for all of these minimum target framework values that are defined. So it should make sure that basically all of these now turn into item definitions. So for all things that maybe are specified as minimum target frameworks .NET 5, I end up with the collection of all these feature flag items. So in this case, I'm switching around the metadata to be the new identities and the existing identities to be inside of this feature flag metadata. And in order to visualize this a bit, I want to show you a debug utility for that. So if I call .build with -bl for binary log, what it will do is create this binary log file, MSBuild.binlog, and this actually contains, again, any log output, but also all the reference project files and some environment information. So there is a nice tool that's called the MSBuild Structured Log Viewer, which is also an open source project that is able to walk me through what happened in this build. So in this case, I want to look for this target that I created. Right, and I can see here this add item feature flags by minimum target framework. By the way, you can also double click here to see the source code. And I can see that this creates a lot of items. So here for all the .NET 5 items, it sets these feature flags. For .NET Standard with this feature flag. .NET Core app actually has multiple. And since we use this add syntax here, those were concatenated using semicolon. And some interesting stuff that we can then do is actually update them. So also inside of targets, there is no update syntax. So we can only set things on all the items using just the definition without include or remove. We could filter this with a condition as well, but we don't need to do here. And what we can then do is we want to set this compatible metadata for all the items to basically see, okay, are we actually building for a target framework that is compatible? So this $target framework is the thing that the project is building for. And then again, we call an MSBuild function. In this case, MSBuild in the .NET 5 SDKs and recent 16.8 MSBuild distributions has this is target framework compatible function. It's actually calling some NuGet APIs to make sure if we're actually compatible. So in this case, I'm using the identity metadata of all these items that we generated. So basically net5, net core app, 2.2, and so on. And just check, hey, are we building for a target framework that's compatible? So you will see okay, this update is actually not visible in the log in here. So you have to kind of take my word for it. But what we then see is another task or another item creation step where we create these compatible feature flag items to do some more shuffling around. So in this case, we can also use item functions on these intermediate items that we just created to filter, like with metadata value, compatible true, that we just filtered. And then we're doing a transformation because we're only interested in the feature flags and actually not the framework. So the concatenation of support ECDSA, support generic host, support, and so on. And since some of them may show up multiple times because like .NET Core App 2.1 and .NET Standard 2.1 are both supported by .NET 5, I want to also call a distinct function. So that is like a bit of like functional programming, just doing a lot of projections and filtering. And so we end up here with the collection of the feature flags that we actually want to set. And then we set a property in here. It's called define constants. This is a property that the C# compilation tasks look for, where we would previously have things in there that we don't want to lose. So something like your configuration, like debug or release, should be in here. So we want to overwrite this value, but keep the previous value in here. We do that by using the $syntax right at the beginning and just add the items semicolon separated that we just created in here as well. We can also see that in the log, define constants, which is now trace, debug, net5, net core, everything that the SDK already has generated for us, and then all our custom feature flags. Right. And if you want to see where this is actually used, we can see that there are some targets in here, and one of them is core compile, which is the actual C# compiler. And again, using the binary, the structured log viewer, we can actually see the MSBuild syntax of the SDK that is actually using just the same things that we also did, property groups and so on, and then calling the C# compile task, CSC, with a lot of things. And all of these, except for the ones that start with underscore, all of these are available to play around and have fun with. And with that, I want to go to the Q&A part.
Okay, thanks, Martin. Unfortunately, your camera dropped out again, but 5 minutes ago. So, but I removed your.
Okay, sorry.
Put just your slides. So maybe
it should be back in right now and maybe last for another 10 or 15 minutes.
it's back. Okay, so first of all, thanks for the interesting talk. Again, for me, there was something to learn. Although I watch all your talks, I hope same goes for the audience. So first of all, I will show for everyone again the repository, and we also have some questions. So
great.
Check the questions. First question was, let me see, how did I want to go? Which one goes first? Okay, yeah, let's start with that question here. Andrei Budayev asks, we have a solution with large number of projects, more than 90. A change in one of the base projects forces all projects to be rebuilt. Is it possible to optimize this?
Yes, it actually is. One of the ways would be to switch to .NET 5. But if I create a demo, sample solution, sample library, sample console, that looks fine. Then I actually want to open this as a folder now, just for right. So in this case, this is a project that references a library, and maybe this was a .NET app, and this is a standard 2.0 library. And what I can do here is ideally create a new file, Directory.Build.props. Let's just run a build. Right, so again, if we do like any change in a library, all of the dependent projects actually have to be rebuilt. What we can actually use now are reference assemblies. So there is a property now, generate reference assembly. I hope I can remember that right. Sorry. Produce reference assembly. Right. This will create a ref folder in here with another DLL file named after your main output. What this has is actually only contains the public API of your project. So like if you have a class with some public members, every time you change that, this library will change as well. But if you only change like private stuff, in this case, maybe create a private string void foo method that does nothing. I believe this will recompile at least once. But the idea is if we then change any code in here, this will not rebuild any dependent project. So this saves a lot of build time. And this is also now enabled by default for .NET 5 libraries and applications. I believe this is why in .NET 5 you will always see these ref folders on all libraries and projects. So this will speed up your compile time as well. And as I've mentioned before, make sure that you don't have any copy to output directory always items, which can basically kill any IDE heuristics as well. So those are the main pain points that I've seen so far in solution build times.
Okay, but that means it would also only work if you don't do multi-targeting, right? So only if you target .NET 5 and not .NET Core.
Exactly.
Yeah. Okay. Good
so
to know.
As long as you don't have any like classic .NET Framework project like an ASP.NET web application or some older WPF applications. So everything that's on the older project system and has to reference a .NET Standard library. If that is the case, and this is also why it wasn't on by default before, and you are like in a .NET Framework project in a classic project system like ASP.NET Classic, and you had a .NET Standard library that actually turned this feature on, your like go-to definition or go-to implementation would just be broken. But since .NET 5 libraries cannot be used by .NET Framework projects. Everything in .NET 5 is basically mostly safe, so this is now turned on by default.
Okay. Next question. That's a question from me. And I'm not exactly facing this issue myself, but I see it in the wild. When do I have to use MSBuild standalone versus .NET MSBuild?
Okay,
Is there
so,
or can you give a brief description what the issue is?
There are basically right now 3 main distributions of MSBuild itself. So MSBuild is there are 2 flavors. One of them that runs on .NET Core, and one of them that runs on like full framework or .NET framework, which also runs in Mono. So actually there are no 4 distributions. So there is the .NET SDK, which bundles build targets and logic for .NET Core, along with a .NET Core version of MSBuild. Then there is like the Visual Studio version of MSBuild, and now also a mono version that's used when you install like Visual Studio for Mac. That is distributed with Mono and also contains some of the build logic that you need in most of the use cases for Mono. And now there is also an MSBuild distribution that's available from JetBrains, which is actually the only one you can use without a license for Visual Studio. So if you don't have like a community license, you can actually not use the .NET or the Visual Studio build tools. And basically it depends on which kind of project you want to build. So for example, if I want to build ASP.NET projects, they actually depend on some web build targets that are just not packed in the .NET Core SDK. So if I have a web project and I try to build it with .NET Build, it would say something like web application.targets was not found or something like that. So it's just a matter of which features or things a project actually depends on.
Okay, good to know.
So for example, if I used Visual Studio and installed the C++ development workload, this would also import like some C++ files, and those would just not be able to build with that, but because the project actually uses this feature. I can actually believe I have some test projects. Yeah, for example, a classic web application would have a CSproj file that starts with something like import common props and then import Visual Studio, V10 web applications, Microsoft web application targets, and so on. And this file and all the tools just don't exist in the .NET Core SDK and aren't shipped with it because these are parts of Visual Studio. So these are kinds of the workloads that are distributed with the tooling you're actually using.
Okay. One more comment from Augusta. I want to point that out. Very handy targeting feature compatibility. So the last thing that you've shown is a much better approach than using generic if directives with the target framework moniker. So yeah, very much agree. And
yeah,
also,
I've seen this a couple of times on Stack Overflow or in GitHub repos of NuGet packages. So yeah.
Also, Andrei Budayev again, who asked the question before. Great lecture. Can you recommend some books about MSBuild, in depth or about optimizations?
So yes, there are books about MSBuild. I'm not sure how up to date they are. This is a bit of it. There are really good books. I forgot the name of the author again, who also worked on MSBuild and is also on Stack Overflow.
Sayed, maybe? I'm not
exactly.
sure about the pronunciation, but
so this exists, but again, what I've seen is in practical usage, it's much more interesting to get to know the things that you can actually customize, like which properties can I set. And so in this case, I'd say really look at the documentation. Again, now there's this project SDK documentation that tell you like a lot of the properties you can actually set, and so on. Yeah, I'm sorry.
Okay, so
especially with new features features that are coming to MSBuild, like using these attributes, XML attributes to set item metadata. I believe that didn't exist 3-4 years ago, well, 4 years ago actually.
But to get familiar, and I think he was also describing some ideas around how MSBuild should be used. I mean, how it should introduce new targets and outline or define dependencies and all of that. So for that kind of stuff, I think it's still quite interesting. And the name, again, for everyone who's interested, I will paste it in the chat. So the name is, I hope I get it right, is Syed Ibrahim Hashimi. I think this is it, if I'm not mistaken. Maybe a last question before we wrap up, and that is, with all those new property items and like for instance what you've shown, what was it, produce reference assemblies, what's the best way to stay up to date with new additions like that? Is it just the MSBuild repository that you're reading, or? Yeah,
so a lot of these things I knew from just following both the MSBuild repository and the SDK repository. Just for a record, there is .NET MSBuild, which has a lot of these core tasks in here, and you can see like what's going on from version to version. And then there's also the .NET SDK, which contains the build logic shipped by the Microsoft .NET.SDK part. Some compile things like C# related files are actually in the .NET Roslyn repository, but you will hardly need to like touch them. And yeah, what I can recommend is once you get familiar with the MSBuild syntax, is to actually look at these SDKs. So if we look at the Microsoft Net build tasks, there are like targets, and there is like what would be interesting in here, publish targets. Just have a look at what things are available in here. So for example, like there are result file publish items that I can do, and what kind of steps are in there. And once you get familiar with that, you can kind of understand how the things are run and then customize based on that. Other than that, I can't give you more information than look at what's documented and then look at everything that maybe does not have an underscore. Okay, good to know. I can say, for me, you are actually the source of truth. And sometimes also Kirill Ozenkov. So you two are both very high on my list. So let's wrap this up. And sorry, I need to see how I can share my screen. Yeah, here, exactly. So for everyone, first of all, thanks for watching. If you need more information, there's some links you can follow. Also, definitely make sure to follow Martin on Twitter. With that said, again, let's switch. Thanks again for joining once more. Thank you, Martin, for being here. It was very interesting, very great, as always. And yeah, see you around. See you.